There are four main types of probability or probabilistic sampling methods. So those are simple random sampling, systematic random sampling, stratified random sampling, and cluster sampling or multi-stage cluster sampling. So let's start with simple random sampling. So simple random sampling literally identifies cases just on the basis of chance alone. So the elements being, so any individual from the complete population according to the sampling frame that we have available, the elements are totally randomly selected. So you have a total sampling frame that includes as much of your target population as possible, maybe the entire target population, and any sort of individual that's on that list, it's just totally random as to who is selected to be in your sample from that list, because your sampling frame is your entire list of your population. So, and when we say random, like it's truly random. So there are actually such things as random number tables, and it's literally just tables and tables of numbers, and you like literally randomly choose, and there is no order to the numbers at all. You can just go through the list, or you can sort of randomly pick, and it's totally random. So you can use random number tables. For phone numbers, there's random digit dialing, and names out of a hat, anything that's truly random. There are also random number generators online. Those are pretty commonly used nowadays. So, but you need that true randomness. If you're just like, I think I'm gonna go through and just pick randomly, but it's not truly random, then it wouldn't be simple random sampling. The key to simple random sampling is that randomness. It needs to be as random as possible so that no cases have a higher or lower likelihood of being chosen. They all have the exact same likelihood of being chosen. So here's why we have some important conditions. You have to have truly random selection. Every population element has to have a known and independent probability of selection. So we know the likelihood of any single person being selected from that list, assuming that our elements are people. We'll just sort of keep it that way to keep it easy. And because it could also be like groups or organizations or anything else, but let's just stick with people. So every person has the same probability of selection, and we know what that probability is because we have our entire sampling frame. We know how many are being chosen, so any individual at any time has the same probability, same likelihood of being chosen, and they're all equally likely to be chosen. Now, this can be done with or without replacement. And so replacement sampling is when you choose an element from the sample, it is then returned to the sampling frame to be sampled again. Now, what this does not mean is that you would have the same person who would be chosen twice. If somebody was chosen twice somehow randomly, you wouldn't include them in your sample twice. That wouldn't make sense. So why then, you might ask, would you ever want to return them to the sample? The reason for this is because it allows the probability of being sampled for every element in that sampling frame to stay the same. Because otherwise, if you take out from your sample as you're sampling and you continue and you sort of leave them out and you don't replace them, then the probability changes. It goes up a little bit with each thing that's taken out. If you take an element out, it's gonna increase the likelihood of everything else being chosen by a tiny little bit. So the only reason you would want to sample with replacement is so that that likelihood of being chosen always stays the same. You don't have to do it that way as long as you are knowing that likelihood of sampling is going to change with every element that's sampled. You don't have to do replacement sampling, but that would be the reason why somebody would do replacement sampling. It's not because we want the same element to be chosen twice. We don't want the same person picked twice. But you want the chance, the likelihood of being chosen to stay the same throughout your entire sampling procedure. So then systematic random sampling is actually very similar to simple random sampling, except it's done more systematically. So what you do is you have the first element is selected totally randomly, so the same process as when you were doing simple random sampling. But then you basically have your entire sampling frame, and so you randomly pick the first one, and then you go however many elements thereafter. So what you would do, you would kind of do this in 3 steps. You would first need to know the sampling interval, and that would be what will become that n that goes right up here. And so you want to divide the entire population, the entire list that you have, by the number of cases that you want in your sample. So if our sampling frame has 750 names on it, and we know we want 150 people in our sample, then our sampling interval becomes 5. So that means we would put that 5 up here where this n is, so that we're randomly selecting from our list and then going every 5th person down the list, because we know we want our final number to be 150. And that would mean we would go to the end of the list and come back to the beginning of the list until we have our full sample of 150. So after you get that sampling interval, then you have to do that first case. And so this is where you have that total randomness, and this is where we keep that randomness for our sample. And this all comes from the fact that the first case is totally randomly selected. So a number within that sampling interval is randomly selected for the first case. So you could do this one of two ways. You could either make that first number completely random within your sampling frame, or sort of the even more systematic way to do it is, and this is kind of what this is referring to, is that you have your sampling interval of 5, and then you randomly choose one of the numbers 1, 2, 3, 4, or 5. So that this would be, you would just make it so you start at the beginning of your list, and one of those first 5 names on the list is going to be chosen, then you go every 5 people after that. So that would be kind of the even more systematic way to do it, as opposed to completely randomly selecting that first one from your entire list. But this is kind of an even easier way to do it. So then you would, of course, after you get your first case, then you get all your subsequent cases by going, all right, so I randomly selected number 2 out of 5, so I'm going to go with the second person on the list, and then I'm going to go 5 down to the 7th person on the list, and then I'm going to keep going down through my entire list until I get my sample of 150. So that's kind of the most systematic way you can do it, while also maintaining that element of randomness, just by virtue of the fact that that first case was identified randomly. But now there are some sort of things to keep in mind if you're going to do systematic random sampling. First of all, it typically is going to give you basically the same level of randomness as a simple random sample would. So this is just an easier way to get a totally random sample without having to just be completely random every time you're picking somebody. It just makes it easier, especially if you got to go through and pick 150 names. It's a lot easier if you can have a more systematic way of doing it. The exception to this, though, and this is a very big caveat that you have to keep in mind if you're going to do something like systematic random sampling, is that if you have a population or your list, your sampling frame, has what's called periodicity. And so periodicity means that the order of the sampling frame, it's not random. There's some kind of regular periodic pattern, so it's not a random sequence. So something like a phone book, or using phone numbers to list people, or student numbers, or something like that. Or maybe even just sort of the last couple of digits of student numbers, because sometimes the first couple of digits have to do with when you started being a student. But anything like that, where that would be totally random if you just made a list based on people's last 4 digits of their phone numbers, or the last 5 digits of their student number, or whatever, or phone book, that would be totally random in the sense that there would be no periodic pattern that would affect the randomness of your final sample. But I've got a picture of an NHL goalie there, because if, for example, we're looking at a list of hockey players and they were ordered by team and jersey number, then because goalies tend to have the number 1, they don't always, but they're much more likely to have the number 1 on their jersey, then that would mean goalies would either be overrepresented or underrepresented, depending on the first case. So if your first case, for example, was 1, then you might end up including every goalie on every team, and then goalies are going to be overrepresented in your final sample. Whereas if you picked, 2 or 3 to start with, then you're not actually going to pick any goalies, or very few. So then you're going to have an underrepresentation of goalies, because so there's some kind of pattern, periodic pattern, that's going to affect that final sample. And so if the list of people is ordered by height, let's say, then you're either going to miss the very shortest people because you're going to sort of skip the first couple and you're going to miss the very shortest, or you're going to not get quite to the end and you're going to miss the very tallest people. And so then that's going to skew your results to make it look like the group is either taller or shorter than they actually are, if that's a relevant variable. So periodicity is something that you have to make sure that essentially the list that you're drawing from in a systematic random sample, it has to also be random. If there's any kind of sequence or order to that list, then you can't use systematic random sampling. You would have to do something to jumble up that list before you start going through and systematically doing a systematic random sample.